Good morning. Welcome to the RISC V Global Forum. It's a privilege to be addressing you today. My name is Guru Chahal. I'm a partner at Lightspeed Venture Partners. My goal over the next 15 minutes or so is to share with you more of an investor perspective on how do we view the RISC V movement, the opportunity, as well as some of the risks associated, or let's just call them areas that we probably need to continue to work on as a RISC V community. A little bit about myself before we dig in. I'm a software engineer by training. I worked in the early part of my career on distributed systems and embedded software, and got an opportunity to write enough firmware to know how difficult it can be to work with existing platforms. Sometime after my more core engineering roles, I moved into go-to-market roles at several startups. Most recently, I was a co-founder at Avi Networks, which was acquired by VMware, and got an opportunity to be an early employee at other startups like Nova Systems before that, which was acquired by Cisco, and Tropus, which was acquired by ABB. Here at Lightspeed Venture Partners, I focus on our cloud infrastructure investments. Part of that is also our focus on systems and semiconductor. I also focus on DevOps, developer tooling, security, and automation tooling for enterprise IT. Before I share with you more about how we think about the investor or investment landscape in a RISC V context, I think it's important to share with you a little bit about Lightspeed and how we view investments, because not every investor is the same. Different people in the investing landscape have different points of view on the kind of firms and the kind of opportunities they look at, and how they view the RISC V landscape. So let me share a little bit about Lightspeed. Lightspeed is a 20-year-old startup in some sense. It's an incredible platform that started as an early-stage enterprise-focused platform, and today is a multi-stage, global, multi-sector platform that invests in companies from the earliest stages to pre-IPO mezzanine rounds. Today, we're investing out of $4 billion of active capital that we raised earlier this year. It includes a $900 million early stage fund, which focuses on seeds, A's and B's, a mid-stage fund, which is about $1.8 billion, and a late growth fund, which is about $1.5 billion. And we take this and a few additional vehicles. These vehicles are primarily targeted on US investments, although the late growth does invest worldwide. Our geographic reach is across US. We've got partners here that invest in US, they invest in China, they invest in India, with partners on the ground. We also invest in Europe with partners out of London, as well as Israel. And across the entire team, we invest as one Lightspeed. And the reason why this is important is it allows us to look at RISC V slightly differently than, let's say, an investor that is purely focused on the US or purely focused on early stage. And this is because we're able to connect the dots across what's happening worldwide in semiconductor development, in systems companies and hardware companies, and be able to use our partners in various geos to either help our investments or even diligence more deeply a particular market trend in that geo and see if it makes sense to invest in another geo. Our portfolio companies on the enterprise side include both SaaS applications as well as IT and engineering infrastructure. In this talk today, we're going to be largely focusing on a context that is driven by our engineering infrastructure companies. This has been our bread and butter for a very, very long time. We've been investing in everything from semiconductors to systems companies, storage, networking, cloud infrastructure companies, security, developer tooling, et cetera, for 20 years now. This goes back to systems companies like Brocade and Riverbed, and then Nutanix as the first hyperconverged company, MuleSoft, AppDynamics, several other really iconic companies that got built over the last 10 years. Today, we're active investors in Rubrik, where we wrote the first check into the company. It's a data management company in the system space with its own hardware as well. That is now a multi-billion-dollar company. We're investors in Pensando. That's another systems company, which is targeting data center re-architecture and reimagination of data center infrastructure, bringing the same benefits that, let's say, Amazon gets out of its data centers using custom silicon. It brings that same expertise, custom silicon, and the system built around it for use by the regular enterprise user as well. We're investors in Aerial, which is another company in the semiconductor space. They're still in stealth, so I won't be able to share a ton of details, but they're very relevant to this conversation because they're in the RISC V space. And as I share with you what's our perspective on RISC V, there'll be some sort of hints on exactly why did we invest in Aerial, but I won't steal their thunder certainly in today's conversation. So let's dig right in. So what do we look for in our early stage investments, and how does that, if you take those criteria and map those to the RISC V market, where's the market at that stage? So let's do that little bit of an exercise over the next 5-7 minutes or so. So we look for 3 key things in any investment that we do: large market, typically an existing large multi-billion-dollar market, or market that's growing relatively fast that could get to that sort of a stage. Because quite frankly, very few things can constrain an opportunity for a company as badly as a restricted market. You know, if the market is if there's just not enough commerce in the system, it's very difficult to support a large, fast-growing company. So we look for large markets, typically in the billions of dollars, if not, tens of billions of dollars. We look for a step function change in one of 2 things: either a brand new technology that is now commercially viable that has come to the market, or a rapid change in market requirements, so that maybe no new technology has come to the fore, but the requirements change so fast that none of the existing products and companies are able to meet this new set of requirements quickly. So there's an opportunity for a new player to come in very quickly, bring the right product to market, and really dominate sort of the next 10 years of that market. So either one of these, I'll give you examples in both. In step function change in technology, about 12, 14 years ago, Flash came to the market with a vengeance. I mean, it completely changed the storage landscape. And that was a step function change from rotating media to Flash, which really fundamentally, which gave companies ability to rethink how various tiers of storage are done. So we were early investors in Fusion IO, again, building on that theme. We were early investors in Nimble Storage, again, building on that theme. We were early investors in Nutanix, which again use SSDs to build distributed storage system underneath their hyperconverged system. And we were early investors in several other companies along that thing. So we invest in semiconductor, we invest in components, we invested in systems companies, we invested eventually in cloud infrastructure companies along those lines as well. On the market requirement side, another example would be, sometimes, for instance, several years ago, the rise of enterprise SaaS is a great example of this. It's not necessarily a step function change in technology, but enterprise buyers suddenly had very little appetite for these long lead times for buying the hardware, deploying and getting it up and running, only to deploy the software application that they want to run and then have to maintain the hardware constantly. And so the requirements just completely changed. They had a requirement that I need to get running as quickly as possible once I've decided what application to buy. And that led to the rise of enterprise SaaS. So that's a great example of how sometimes market requirements just open up an opportunity for someone to come in and dominate the next 10, 20, 30 years of that space. And the third thing we look for are teams that have context in that market, right? They understand deeply what's going on in the market, and they have the aspiration to take advantage of 1 and 2, large market and a step function change in the market, to build an iconic company, to build a to build a generational company, sort of the next number 1 or number 2 player in that market. So those are the 3 things we look for. Let's take especially 1 and 2 and see how that translate to how we think about the RISC V market. Let's start with the market itself. So if you look at microprocessors today, within plus minus 10, 20% or so, the global market for microprocessors today runs at about 80 billion or so. And so this is not valuation, this is just commerce. This is spend on microprocessors up to about 80 billion every year. And that entire market is dominated by a few large players in different segments of the market. So Intel and AMD, increasingly now, certainly in the last few years, dominates a certain section of the market. Intel's today valued at over $200 billion. NVIDIA dominates another part of the market. They're valued, between $250 to $300 billion. The last time I checked, it was almost $300 billion. What an amazing company over the last few years. They've just done an incredible job over the last decade in building that company out and dominating a part of the ecosystem. And then ARM, another amazing player that, thanks to some really interesting IP, has really dominated the market for a certain kind of microprocessor. And they were last valued at about $31 billion. So it's a large market that can support really, really large valuation. So you can build an interesting company as long as there's an opportunity. There's something in the market, there's a pain point that you're able to go ahead and address. So what's a pain point? Now, the interesting thing is all these companies, whether it's the Intel of the world or the ARMs or others, the existing players in the market, they have been in the market for a very long time. And these are largely closed architectures. They're tightly controlled by the parent. And so customers who want really flexible designs to meet the needs of next generation workloads, they are unable to exercise the same degree of flexibility and customization that they really want to. So they're stuck with inflexible designs, lack of transparency on roadmap and how the mothership makes its decisions, and certainly often in a lot of cases, extremely large and onerous fees and royalties, etc., which then in a weird sort of way, it actually constrains the market because you're unable to take the product into new parts of the market that might not be that might have different cost profiles. Like you might not have the luxury to pay the kind of royalty or fees to an existing player that you want to. So that's a pain point. And the step function change is a few things. The first one, and I think the most important one, is certainly in our perspective, is the rise of domain-specific architectures. Over the last several years, there are certain kinds of workloads that have grown to a size now that it just makes sense to have dedicated silicon, to have dedicated hardware that is optimized for running that workload at the highest possible performance or at the lowest possible power or some combination thereof, or maybe with a very specific sort of feature set. So AI ML is a great example of that. There's been this Cambrian explosion of companies that want to build hardware dedicated to run AI and ML workloads just because they're so power hungry and so compute intensive. And so that's a great example of the rise of domain-specific architectures and an investor opportunity. Hundreds of millions of dollars have been invested in just the AI ML silicon companies to date. And a lot of these companies are now, the revenue cycles are kicking in, and we're seeing some very interesting numbers, which gives us a lot of hope that other domain-specific architectures might also see the same kind of revenue traction once the technologies get built out. Some of the areas that we're tracking very closely: IoT, 5G, cloud acceleration. I'll come to that in a second again. Autonomous vehicles, because of their constraints for how quickly and how low latency the processing needs to be right at the edge. Intelligent storage. I think Western Digital, one of the biggest sponsors of RISC V, has done some amazing work there, bringing some really innovative platforms to the market, thanks to some domain-specific decisions they've taken along RISC V. Industrial automation is another area we're pretty excited about. I mentioned cloud acceleration. I'll give you a quick example. A few years ago, AWS, Amazon bought this company called Annapurna, and then used that silicon and derivatives of that silicon to build really customized silicon to do CPU offload for certain kind of workloads for the AWS cloud, which gives them a huge competitive advantage over both enterprises who are unable to do that, obviously, because they can't purchase the silicon, as well as other cloud providers as well. So we're investors, for instance, in a company called Pensando that now brings those same advantages that Amazon has to every data center out there, every enterprise out there. So again, this notion of a domain-specific architecture, and architecture is meant to offload networking or storage or security cycles off the CPU, that is now at those workloads and those needs are at a scale where you can have dedicated silicon just to do those functions. So we're pretty excited. That's a first step change. The second one is just this massive increase in the permutations and combinations of power, performance, and feature set that the market needs. It's no longer enough to just look at a SKU list of an existing vendor and say, okay, I'll go with this. for IoT or for industrial automation or for these various use cases, as compute becomes ever more pervasive in our lives, every unique use case, every unique device might have a different point on the power, performance, feature sort of matrix that they want to land at. And so unless you have, so there's a lot of demand for that, and unless you have, a near infinite number of combinations or flexibility in sourcing a microprocessor exactly of that type, you're beholden to whatever the existing vendors are going to get you. The third one is the rise of open source as a mechanism of change, which we've seen this in software, and now with RISC V, we're beginning to see this in hardware as well. And then the final one, and this this is really, really important, is that over the last several years, there's been a lot of maturity in the semiconductor design and manufacture cycles. So it has become, I'm not going to say cost effective, but somewhat more cost effective compared to, let's say, 5 or 10 years ago to bring a chip to the market, right? So that allows us on the venture side to actually look at an opportunity in the RISC V space or other adjacent parts of this market as a venture investment. So let's talk about the RISC V opportunity. RISC V, as you know, it goes without saying, it presents as a massive open source alternative to inflexible ISAs from existing vendors. And this is important for us as investors, because we truly believe that once you standardize on an open ISA that is extensible, that is flexible, it will lead to innovation both below that ISA line in unique and interesting kinds of hardware that companies will bring to the market to meet the needs of those, whether it's domain-specific architectures or a particular need in the marketplace along that power, performance, and flexibility curve or feature curve. So you'll see innovation below that line, but you'll also see innovation above the line where, for instance, software developers might say, my application does a kind of task, and there's this particular task that it does all the time. And if you're at scale, if the software is going to run at scale, maybe there's an opportunity to add a unique instruction, extend the ISA, add some unique instructions, and then be able to work with some hardware companies to actually even support that. So again, that's a conversation now you can have thanks to RISC V. And so that leads to transparent, secure, developer-friendly, and highly customizable solutions. And most importantly, from our perspective, it brings flexibility where it's needed most. We believe on the investor side, certainly as Lightspeed, that there is a need for embedded compute, for embedded microprocessors everywhere, everything, not just your phones, but everything has an opportunity. There's an opportunity to embed logic in almost everything. And our investment in Ariel is along those lines. How do you make sure that systems companies can source highly performant and yet extremely power efficient cores and architectures to meet their needs? And they can draw the line on, or they can pick a dot anywhere in that matrix along, power, performance, and features, and say, this is what I want. And then, a company or a set of companies make that available. So that's pretty exciting to see. I think, we're in the early innings of this journey, and I think there's going to be a lot of innovation along that line. And then at the end of the day, RISC V increases competition. For us, it's that simple. When there is no competition, there's no venture opportunity, there's no investor opportunity. Because frankly, the existing players in the market tend to carve the market up in a relatively stable fashion, and then keep going to war along that. But there's very little opportunity for a new player to emerge. But when there's increased competition, through innovation like RISC V, it's great for customers, it's great for startups, it's great for investors too, on a more selfish note. But like I said, we're very, very early in this journey. There's a lot more that needs to be done. It's not just enough to say, that we need to have great cores, but we need more maturity around. It's not just enough to have commercial grade, high performance cores, as a lot of companies are working on. We need a tooling and software ecosystem, and there could be several options for these. Maybe we can look at some existing ARM or MIPS, tooling that could be transferred or could support RISC V. Maybe large companies could throw even more weight, and this is where I'm looking at, the existing large systems vendors, maybe they can throw more weight and accelerate the ecosystem by committing to RISC V architectures and nurturing the RISC V community. And the best part is it's in their interest. I gave the example of Western Digital earlier. They're not doing it just out of a sense for duty to the community. They're doing it because it's in their commercial interest. It allows them and other companies to bring innovative products to the market that give them a unique edge. And so it's great for them as well. So I'm looking forward to that. I think this is an area that as an investor, I worry about the most. Who's working on the tooling? Who's working on making sure that RISC V can be absorbed into systems companies more broadly by almost anyone, any developers, as quickly as possible. So I'll end my comments there, but I'm always accessible over email at guru@lsvp.com. I'm looking forward to the questions and a robust discussion after this one. Thank you for your time this morning.